I would like to say hello to everybody who is watching the video right now. And today I will be covering L'Hopital's rule with an overview of what it is and a couple of examples of it. So when do we use L'Hopital's rule? If we have a limit as x approaches a of f of x over g of x in indeterminate form, such as 0 over 0 or infinity over infinity, then the limit can't be evaluated simply by substitution, because if we simply substitute, then we're supposed to get 0 over 0 or infinity over infinity, and there's no way to calculate that. So we have to use L'Hopital's rule, and I'll explain what it is later on. But if the limit isn't in indeterminate form, then we can't use the rule. Then we just use other means of evaluating the limit, for example, substitution. So other examples of indeterminate forms other than 0 over 0 and infinity over infinity are the following: infinity minus infinity, 1 to the power of infinity, infinity to the power of 0, and 0 to the power of 0. But we can only use 0 over 0 and infinity of infinity over infinity as indeterminate forms in L'Hopital's rule. So any form other than that, for example, infinity to the power of 0, we have to manipulate the limit into the indeterminate forms 0 over 0 or infinity over infinity. I hope that's clear. So, in other words, if the indeterminate form of the limit after substituting is not the top two, 0 over 0 or infinity over infinity, then the limit has to be manipulated into those two forms. So, also, an important notice, very important. Only if and only if after solving the limit by substitution you get an indeterminate form, do you proceed to use L'Hopital's rule. So, if you don't get an indeterminate form, you can't use L'Hopital's rule. This is very important because it will mess you up a lot of times if you just don't substitute what x approaches into the limit and just jump to using L'Hopital's rule, because that can really throw you off. It can throw off your answer. So how do we use L'Hopital's rule? So pretty much what is it? So if we have a limit as x approaches a of f of x over g of x in a indeterminate form, then the limit as x approaches a of f of x over g of x is going to equal the limit as x approaches a of the derivative of f of x over the derivative of g of x. So we don't use the quotient rule when taking the derivative of f of x over g of x. We take the derivative separately. And that's pretty much it for the actual rule. And then we substitute a again into the two derivatives, into the derivative of f of x over the derivative of g of x. We substitute a into that, and if we get an answer that isn't in indeterminate form, then that's our answer. But if we get an indeterminate form yet again, then we have to repeat using L'Hopital's rule. We have to repeat the same thing. So first example, I'll read it to you. The limit as x approaches 1 of x cubed minus 4x plus 3 over x minus 1. So the first step will be to identify whether we can use L'Hopital's rule. And we do that by evaluating the limit using substitution. So we just substitute 1 into x cubed minus 4x plus 3 over x minus 1. And we get that that is equal to 0 after substitution. And our second step will be, since 0 over 0 is indeterminate, we can use L'Hopital's rule. So now we'll have to take the derivative of both the top and the bottom separately. So same thing I said here. So we take the derivative of both the top and the bottom separately, and then we evaluate the limit. So the derivative of the previous function will be 3x squared minus 4, and the bottom will be 1. And now we just substitute 1. 3 times 1 squared minus 4 over 1. That's going to simplify to negative 1. So since that isn't an indeterminate form, the negative 1, obviously not, that's going to be our answer to the previous limit that we had. Alright, our second example is here. The following. The limit as x approaches 0 of x cubed minus 5 over x squared minus 3x plus 1. So the first step is again to identify if we can use L'Hopital's rule. Don't skip this step. This is a very important step, as I previously mentioned in my important notice. So when we substitute 0, we get 0 cubed minus 5 over 0 squared minus 3 times 0 plus 1. And that is going to be equal, that is going to simplify to negative 5. Now, you might think that we just go to L'Hopital's rule, but we don't. Here it's important not to go to L'Hopital's rule because negative 5 isn't an indeterminate. So we don't go to L'Hopital's rule, pretty much. And negative 5 is going to be our answer, actually, in fact. Yeah, that's pretty much it. So if you don't see why we're not going to do L'Hopital's rule, well, it's because negative 5 isn't 0 over 0 or infinity over infinity. It isn't an indeterminate. So that is just going to be our answer, since we could just solve the limit using substitution. Alright, our third example is the limit as x approaches 0 of sine x over x. Our first step is to identify whether we can use L'Hopital's rule yet again. And so we just substitute 0 into sine x over x. And that simplifies to 0 over 0. Since 0 over 0 is indeterminate, we may proceed with L'Hopital's rule. So now we can just use L'Hopital's rule. Sine x to get cosine x, and we take the derivative of x to get 1. So we have the limit as x approaches 0 of cosine x over 1. We substitute in 0, and we just get 1. So that would be our answer. Alright, our fourth example is a little bit more complicated, and you'll see why. So we have the limit as x approaches infinity of x to the power of 1 over x. So our first step is going to be, again, just as we did in the previous three examples, a very important step, is to identify if we can use L'Hopital's rule. So what do? We just substitute infinity into the limit. So we get we get infinity to the power of 1 over infinity, and that's going to equal, simplify to infinity to the power of 0. And our second step is, since infinity to the power of 0 is indeterminate, we can proceed with L'Hopital's rule. So, but it isn't that simple, because infinity to the power of 0 isn't in the indeterminate form we want. It's not in 0 over 0 or infinity over infinity. It's not in that form. So we have to manipulate x to the power of 1 over x, as we do. So we have to write x to the power of 1 over x as a fraction. So we can let y equal that. And then ln y is going to equal ln of x to the power of 1 over x. And that's going to equal ln x over x. I hope you see that. That's just a property of logarithms. So we know that ln y is equal to ln x over x. That's what we get. And now we can just substitute that again into... now we just substitute infinity once again, just to check again that we can use L'Hopital's rule for the limit ln x over x. So now we plug in infinity into ln x over x, just to check if we can use L'Hopital's rule once again. So once we plug in infinity, we get infinity over infinity. And since infinity over infinity is an indeterminate in the form we like it in, we can use L'Hopital's rule. So we take the derivative of the numerator and denominator separately at this point, and the derivative of ln x is 1 over x. The derivative of x is 1, so we have 1 over x over 1. We plug in infinity, we substitute infinity, and we get 1 over infinity, and that simplifies to 0. But you may think that this is our answer, but it isn't, because if you can remember, ln x over x is equal to ln y. So in fact, 0 isn't equal to x to the power of 1 over x. It's equal to ln of x to the power of 1 over x. So the next slide will explain what we do at this point. So this last step gives us that ln y is equal to 0. Ln x to the power of 1 over x is equal to 0. And that means that y is equal to 1. So we just solve the equation for y. And since we let y equal x to the power of 1 over x in the beginning, the limit as x approaches infinity of x to the power of 1 over x is in fact 1. And that's our answer. So that's it for the examples. Now let's go to the overview, the summary of everything we did. So in each of the examples, we start off by solving for the limit using substitution. So we do that to check if we can use L'Hopital's rule. And the second step, actually part of the first step as well, if and only if the limit is an indeterminate form, may you proceed to use L'Hopital's rule. So if it isn't an indeterminate form, such as 0 over 0, or the other ones I listed before, then we absolutely cannot use L'Hopital's rule, and it'll just mess you up, and you can probably solve the limit in another way, for example, just using substitution. So if it's an indeterminate, other than 0 over 0 or infinity over infinity, then you need to manipulate the limit. So that's what we did with the limit as x approaches infinity of x to the power of 1 over x. Since it was in the form of infinity to the power of 0, we had to manipulate the limit. And so we have to do that to convert it to the form 0 over 0 or infinity over infinity. So now we take the derivative. After we do that, we take the derivative of the numerator and denominator separately. And so that's really what L'Hopital's rule is. Taking the derivative of f of x over the derivative of g of x, and evaluating the limit using substitution again. If the limit is still in determinate form, then we need to repeat steps 3 to 5. So if it's still in the form 0 over 0, then we need to take the derivative of the top, the numerator, and the denominator yet again. But if it isn't in indeterminate form, and if it's just something like -5, just a number, then you have your answer. Wow, thank you. Thank you for the applause. Thank you for watching. I really didn't expect the applause, but thank you.